Hi guys, in this video we're going to go over work. We'll define what work done is and we'll calculate the net work done object. For this section you should already have some knowledge of free body diagrams as well as what is displacement. So we'll just do we'll go over the definition and do a couple of examples. There's a few definitions on the screen. My favorite one is the second one, where it says work done in an object by a constant force is a product of the magnitude of the force, the magnitude of the displacement, and the angle between the force and the displacement. Actually, what you really should know is just this formula here. Whatever states its words is actually written quite compressedly in this formula. So this formula should be given to you in the formula sheet. So if you just remember that, you should be able to remember the definition quite easily. We'll just do some quick examples just to get you into understanding it. It's quite simple, but what you should already know is that W is work done in joules, and you have the magnitude of force in newtons, magnitude of displacement in meters, and the angle between the force and displacement. That just explains what the formula does. Right. So I'll do a quick example. We'll do a few in this video. Let's start off with a simple one here, where it says a parent pushes down a pram with force of 60 newtons at an angle of 35 degrees to the horizontal. The pram is moving on a frictionless surface. If the parent pushes the pram for a horizontal distance of 35 meters, how much work is done on the pram? Right, so let's write down the formula for work. So we know that work is equal to force displacement cos of theta. Okay, so we know that force is equal to 60 newtons. Your displacement is equal to 35 meters, and theta is equal to 35 degrees. Sorry, this is 35 meters, not 3 meters. If you want to draw a free body diagram to understand what's actually going on, you know the displacement is this way, and the force is acting there. That's your force applied, and this is your change in x displacement that way. So the force, this is the angle between. That's your theta. This here, this is your theta. It's very straightforward. You just have to plug in values now. So it's given to us. We have 60. Displacement is 35, and cos of theta is 35 degrees. You get a final answer of work done is equal to 1720 joules. Just remember that theta is the angle between the displacement and the force. That's it. It's always the angle between the two. The next one will help you understand that again. So if we move on to the next example, it says how much work done by the force is required by a force 3000 newtons to lift a lift 6 floors vertically at a constant speed. The distance between the floors is 6 meters high. So what I like to always do is write down the formula. Usually get a mark for that. Work is equal to force displacement cos theta. Write down what's given as well. We're given that the force is equal to 3000 newtons. The displacement is equal to 6 meters times 6 floors. That means it's 36 meters. Okay. Now, this we just have to read the question. A lift goes upwards, right, vertically. So that's your displacement. It's going upwards vertically. Now, the force will also go upwards to lift the lift upwards. So your force will also be this way. So what is the difference? What is your theta? Where theta is the change or the distance or the angle between the force and displacement. In this case, it will be equal to 0. So you might think automatically work done is equal to 0, but that's not true, because cos of 0 degrees is actually equal to 1. So if we substitute values in here and we plug it into our calculator, we get that work done is actually 108,000 joules. Just remember, very importantly, that cos of 0 is equal to 1 cos of 90 degrees is equal to 0. So if there's ever a vertical force applied, so if an object is moving this way, that's your displacement, but the force applied is that way, the angle between is 90 degrees. This is 90 degrees. So that means theta is 90 degrees. That will mean that the work done by this force applied will be equal to 0. That's all you have to remember. This is quite important here. Just remember this fact. You should be good. We'll do one more example just to illustrate positive and negative work done. Alright, it says a 20 Newton force is applied to push a block across a frictional surface at constant speed for a displacement of 5 meters to the right. The block has a weight of 20 newtons and the frictional force is 20 newtons. Determine the work done by the following forces: normal force, weight, applied force, and frictional force. So, block is moving to the right. So let's just draw this. Okay, let's just write down the formula since it's a work type of question. Theta, cos of theta, right? Alright. Let's draw. There's quite a few forces here, so we can just know what we required. So we know there's a force applied, and this is the direction of the block. It says it's moving to the right, so we also know that. That's a displacement. This is a force applied, and we got a frictional force here, your weight, and your normal. Right. Okay. So first things first. Let's calculate weight. Let's do the weight and the normal, because you see that normal is perpendicular to the surface. Remember, we just said that cos of 90 degrees, or even if it's cos of minus 90 degrees, both of these will equal to 0. So since the normal is perpendicular to the surface, work done by the normal is equal to 0 joules. By the same logic, we can say work done by weight is equal to 0 joules because the weight is perpendicular to not the surface, but the displacement. So displacement. In this case, the displacement. So in both of these, the angle theta will be equal to 90 or minus 90 degrees. Right, let's do the applied force first. So we can say work done by applied force is equal to F displacement cos of theta. The force applied will be given as 20 newtons. So we got 20. The displacement is 5 meters. 5 meters. And the angle between the displacement, so this is your displacement and the force applied is the same, therefore it's going to be cos of 0, and that will give you a total of 100 joules. Right. Let's do the work done by the frictional force. So that's going to be applied frictional force, displacement cos of theta. Frictional force says that it's 20 newtons. Sorry, the frictional force is 20 newtons. Displacement is still 5 meters. Cos of, what is the angle between? So we got your displacement that way, frictional force is this way. That's a friction. That means that this is your theta. In this case, theta is 180 degrees. If you plug that into your calculator, you're going to get minus 100 joules. And that's how you get negative work. It's important to note that the net work done can be negative. It's not necessary that it always be positive. So if you calculate the net work done, so net work is equal to work by the normal plus work by the weight plus work by force applied plus work of the frictional force. That's going to be equal to 0 plus 0 applied force plus 100 minus 100 to give you work net equal to 0 joules. That's how you do these types of questions. Hope you learned something from that. Thanks, guys.